All right, college algebra, we're looking at evaluating logarithms in section 4.4. All right, first thing we're going to look at is the natural base. The limit as a number n approaches infinity of this expression right here. And what that means is as n gets very big, what does this approach, this value here, what does it approach? Well, if I put 10 in for n, I get this. If I put 100 in for n, I get that. If I put 1,000 in, 10,000, 100,000, 1,000,000, this is what I get. And notice here how it's kind of leveling out at 2.718. And in fact, E is the natural base, and it's this right here. It's kind of like pi. Pi is 3.14. This is a irrational number, just like pi is. It goes on forever. But this is used quite a bit in logarithms and exponents. It's used quite a bit. So we're going to use this in this section, which gives us the natural log. The natural log, Ln, is a log of base e. When you see Ln, that just means log of base e. So just as we have these properties we showed you before, okay, for logs, we have these properties here, the same ones. Just log base e of e, natural log of e is 1. Log base e of 1, any log base of 1 is 0. And these other ones as well. Okay? There's one on here that's not, like right here where we do log base b of m equals log of m divided by log of b. And we don't have to do that for natural log because there's just a button on the calculator to do natural log. So we don't have to do this division thing. All right, well, let's look at some evaluating. First of all, we got a key term here we need to look at. A base e logarithm is called a natural log, whereas a base 10 log is called a common log. Now here's something right here. When you have log of base 10, you can just write log. You don't have to write the 10. In fact, if I have like log of 5, log of 5 is just log base 10 of 5, and I don't have to write the base. Right here, number 2, why is log base 2 of 0 undefined? Well, log base 2 of 0, what does it equal? What does it equal? Well, let's change it to an exponent. There's my base, and I switch these two. So log base, or I'm sorry, 2 to the x power equals 0. Well, 2 to what power equals 0? It's not possible. So the answer here is B. There's no power of 2 that yields a result of 0. Okay. Now let's look at this. Number 3. Between what two consecutive integers must log base 2 of 14 lie? All right, if you look at log base 2 of 14, change that, you know, what does that equal? Change that to an exponent. So 2 is my base, and I switch these. So 2 to what power is 14? All right, 2 to the third power is 8. 2 to the fourth power is 16. So since this is 14, it's got to be between 8 and 16, right? So that means x would have to be between 3 and 4. So 3 and 4. Right here, find the exact value, log 10 of 8. Now remember, there's no base here, which means automatically 10. Those cancel. That's just 8. I have log 10 of 52. These cancel. That's 52. I have log of 10 to the 19. Guess what, boys and girls? It's 19. These cancel. Okay. What about this log of 0.01? Now right here, this is log 0.01 is 1 over 100. Let me get in the screen here, huh? Log of 0.01 is log of 1 over 100. Now 1 over 100, that's 1 over 10 squared. 100 is 10 squared, which means that's 10 to the negative 2 power. And those cancel, negative 2. Or you could just type in. I mean, you just simply can type this in. You don't have to worry about doing and knowing all that stuff. Just do log of 0.01. And you get right there, -2. Use a calculator to do this one here. All right, so log of 19. Right there it is, 1.278. You see my answer right there. Now it says round at 4 places, so right here. All right, here you go. These cancel. It's just 8/3. All right, look at this one. Since e to the 7's in the denominator here, I can move it up and make it -7 exponent. Those cancel, -7. Use a calculator here to type that, it's just natural log 55, 4.0073. Okay. All right, here's a problem. All right, it says outpatient surgery as a percent of total surgery at a hospital has grown. The logarithmic function f of x equals this right here. Okay. Where x is the number of years since 1900 is the best fitting logarithmic model. Use the function to estimate outpatient surgery as a percent of total surgeries in the year 1997. All right, well now how many years since 1900 is 1997? That's 97. So that's what x equals. So basically I'm just going to type this in and I'm going to put 97 in for x right there. So we'll do that, all right? -1310 plus 306 natural log 97. And there it is, 89.86, which rounds up to 90. 90%. And you can see the answer right there. So in 1997, the percent of outpatient surgery is 90%. Number 11, find the common log of this. So we're just going to do natural log of that. So just type it in. Not natural log, log 0.0708. And I get this -1.1499, which is 1.15. Okay. Log of this right here, we're going to type in. Now here's what I'm going to do. I'm going to type it in 2 ways. Since I got a product here, I can do log of 370 plus log of 25. See, since it's a product, I can split it up into 2 logs like that. That was one of our properties. All right, so I'm going to type it in this way. Log 370 times 25. And I get this right here, 3.966, which is right. You can see the answer here. But I'm going to type it in this way. Log 370, close up parentheses, plus log 25. And look, I get the same exact answer, which shows us how our properties are equal. We're just typing this in, so I'll let you do those, okay? Number 15. Okay, find the decibel rating of a sound right here having intensity, oh my goodness. All right, this is 10 billion times the initial intensity. With initial intensity, where I sub 0 is the initial intensity. All right, so what this means is I sub 0 is your initial intensity of a sound, and then as it increases, the decibel rating goes up. All right, so basically what I'm going to do here is I got D equals 10 log of I. I'm going to put a capital I like this. Okay. So right here, this is the intensity right here. So that means I'm going to have this 10 log of 10 billion I sub 0 over I sub 0. And these cancel out. So it's just, I'm just going to type this in right here in the calculator. All right, so if I type that in, I've got the 10 up front, log, and let's see, 3, 6, 9, I got 10 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there it is, 100. And you can see my answer right there. Okay. So that's the decibel rating. 100 is the decibel rating of the intensity that's 10 billion times the original intensity. Okay, part B says, if the intensity of a sound is doubled, by how much is the decibel rating increased? Okay, so that means if my intensity is doubled, that means I'm going to have this. Okay, because I'm going to double the original intensity. Which these cancel off, so I'm just going to type this in: 10 log base, or log of just 2. All right, so 10 log 2, and I get 3.01. Just I think it says around the nearest integer, which is just 3. You can see that right here, 3 decibels. Okay, right here, the magnitude of an earthquake. Now, we talked about the Richter scale before in class. I'm sure you've heard of the Richter scale about an earthquake. This is how they find the Richter scale right here. It's log base 10 of I over I sub 0, where I is the amplitude registered on the seismograph 100 kilometers from the epicenter of the earthquake, and I sub 0 is the amplitude of a certain size. Find the Richter scale rating for amplitude of this is 100 million times the original. So basically, here. Okay, so here's my Richter scale, log base 10 of I over I sub 0. So if my amplitude is this, then that means I'm going to have log base 10 of 100 million I sub 0 over I sub 0, and these I sub 0s will cancel. So basically, I'm just typing this in right here. Okay? Which means, here, since it's log base 10, I just type log. I'm going to do 100 million. And look there, I get 8. And that's the Richter scale 8, which is terrible. The Richter scale, if you have an earthquake of size 8, that is destructive, which means that's 100 million times the original intensity. Okay. Right here, use the change of base theorem. Okay, now basically what I'm going to do here, this is log base 7 of 0.52, so I'm going to do log of 0.52 divide by log of 7. Okay, so let's type that in. Log 0.52, close it up, divide by log 7, close it up, and there it is, negative 3361. You see the answer right there. Use change of base here. So what I'm going to do there, I'm going to type in log of 4 divide by log of 1/3. Okay, so log of 4 divide by log 1/3, and negative 1.26 right there. We're almost done. Use change of base to do this one. So right here I'm going to do log 25 divided by log pi. Okay, let's type that one in. So log 25, close it up, divide by log pi. And 2.811 right there. Okay, and number 20, which of the following is equivalent to 5 ln 2x? Okay, all right, since there's a 5 out in front, I can put that back as an exponent so it looks like this. So since I have a multiplier up front, I can put it as an exponent of the argument. Which means I would have this then, 2 to the 5th power is 32, and then x to the 5th power would be x5. And so do I see that over here? Yep, right here, this one. Okay, So I think it pretty much knocked this out. So that's the evaluating logarithms. If you have any questions, just let me know. All right. So have a good rest of the day.